All right, Algebra 2, we're going to talk about, like I told you before, we're going to talk about a specific kind of sequence now. Okay, this is called an arithmetic sequence. It looks like arithmetic, but we call it arithmetic. An arithmetic sequence is a sequence in which the difference between any two consecutive terms is constant. And we call that difference the common difference, and we use D as the variable for that common difference. So let's look at some examples. For number 1, all it says here is, first of all, determine whether it's arithmetic, and if it is, find what D is, and the next 3 terms. 5, 8, 11, 14, 17. So the first thing we have to know is it arithmetic? So we take this, we say 8 minus 5 is 3. 11 minus 8 is 3. 14 minus 8 is, not 8. 14 minus 11 is 3. 17 minus 14 is 3. So yes, this is arithmetic, and D equals 3. And the next 3 terms are 20, 23, and 26. So to find D, you always take this minus this minus this, and see what the difference is between them. Okay, let's look at number 2. Is this arithmetic? 23, 16, 9, 2, negative 5. Well, let's see. 16 minus 23 is negative 7. 9 minus 16 is negative 7. 2 minus 9 is negative 7. Negative 5 minus 2 is negative 7. So yes, this is arithmetic, and D equals negative 7. Okay, D is going to be positive if the numbers are going up. D is going to be negative if the numbers are going down, when we look that way. Okay, number 3. 1, 2, 3, 5, 8. Okay, first of all, is it arithmetic? 2 minus 1 is 1. 3 minus 2 is 1. 5 minus 3 is 2. So, nope, we don't even have to check anymore. It's not arithmetic, and we're done with that one. Number 4, negative 6, negative 8, negative 10, negative 12, negative 14. Okay, is it arithmetic? Negative 8 minus negative 6 is negative 2. Negative 10 minus negative 8 is negative 2. Negative 12 minus negative 10 is negative 2. And negative 14 minus negative 12 is negative 2. So yes, it is arithmetic, and D equals negative 2. All right, number 5, is it arithmetic? Negative 20, negative 10, negative 5, 0, 5. Just by looking at it, you can see that no, it isn't, because negative 10 minus negative 20 is 10, and negative 5 minus negative 10 is 5. So no, it isn't. Number 6, this one up here for number 4, the next terms would be negative 16, negative 18, and negative 20. All right, number 6, negative 35, negative 23, negative 11, 1, 13. Is it arithmetic? Negative 23 minus negative 35 is 12. Negative 11 minus negative 23 is 12. 1 minus negative 11 is 12, and 13 minus 1 is 12. So yes, it is arithmetic, and D equals 12. So the next terms are 25, 37, and 49. All right, here is the formula for an arithmetic sequence. The nth term for an arithmetic sequence can be found with this formula. an equals d times n minus 1 plus a1, where a1 is the first term and d is the common difference. Okay, so let's look at the next examples. Write a rule for each sequence and then find the indicated term. So number 7, we need to know, in order to use this equation up here, we need to know d and we need to know a1. So for number 7, a1 is -5 and d is 4. Okay, all of these sequences right here are arithmetic. You don't have to check to see if they are. They're going to be. So then we're going to say an equals d times n minus 1 plus a1. And we're going to simplify this so that it looks nicer. So we're going to distribute the 4 and get 4n minus 4 minus 5. So we'll get an equals 4n minus 9. And there's our rule. Now it says find a24. a24 is 4 times 24 minus 9, which is 87. Okay, so see, this formula right here for an arithmetic sequence is an explicit formula, which is very helpful for when you're finding a24. We don't have to write out all the terms. We can just stick the 24 in for n, and it doesn't matter what the terms are right before it. All right, let's look at number 8. 20, 11, 2, -8. Okay, a1 is 20, and what is d? D here is -9. Okay, 11 minus 20, 2 minus 11, -8 minus 2. I think I have that wrong. Okay, well, let's just do this, and we're going to do it just with these terms because it works for those. Let's see. I think it's time for me to take a break. Yeah, that 8, it was wrong in there. Maybe your notes are different, but we'll do it with this. We're going to say an equals d times n minus 1 plus 20, and then distribute the -9, and we get an equals -9n plus 29. I already wrote the 9 up here. That's wrong. Plus 29, and it's asking us for a 15. So all we have to do is do -9 times 15 plus 29, and we get -106. Okay, number 9. -6, -9, -12, -15. A1 is -6. D is -3. And we find that by saying -9 minus -6 is -3. -12 minus -9 is -3, and so on. So our rule is going to be, I'm going to write it over here, our formula. Our rule is going to be d times n minus 1 plus a1. And distribute this. and we get an is -3n minus 3. And it's asking us for a 38. Aren't you glad you don't have to write them all out? You can just stick the 38 in there and you get -117. And let's look at number 10. We've got 8, 9.5, 11, 12.5, ... A1 is 8, D is 1.5. Okay, we're going to find that by saying 9.5 minus 8, or 11 minus 9.5, and so on. So our AN is D times n minus 1 plus A1. So distribute that, 1.5n minus 1.5 plus 8, and we get AN equals 1.5n plus 6.5. And we're looking for a 48. So all we have to do is stick a 48 in for the n, and you should get 78.5. All right. If you're given the next part, if you're given the terms, if the given terms are part of an arithmetic sequence, write a rule for the sequence and then find A12. All right, number 11. We've got A1 equals 3 and A3 equals -7. So let me put our formula up here. Okay, there's our formula. There are 4 unknowns here: AN, D, N, and A1. So if we know 3 of them, we can find the 4th one. So here we know A1, so we got that one, and we know A3, so we can use that. And if we're using A3, then we can use N, so we don't know D. So we're going to say A3 equals D times 3 minus 1 plus A1. Okay, see what I did there? I don't know what D is, so I'm going to use A3 as AN and then substitute the 3 in for N to find what D is. And I'm going to simplify this equation. 3 minus 1 is 2, so this is 2D plus 3. So I get D equals -5. So to solve this equation, I need to do 2 steps. I first had to find D. Now I know D, and I know A1, and so I can find AN. So AN is D times n minus 1 plus A1. And simplifying this, I get AN is -5n plus 8. So there's my rule. And then it asks me to find A12. So I'm just going to put a 12 in for n, and I get -52. All right, let's try another one like that. Number 12. I have A1 is -17 and A24 is 6. I don't know what D is, so I'm going to use these 2 things to find D. So I'm going to put this in for this, which means I have to put 24 in for N, and I know A1. I'm going to solve this. 24 minus 1 is 23, and I get d equals 1. So there's the first part of my equation. Now I can use this and this to write my rule. an is d times n minus 1 minus 17. Since d is 1, I don't really need to distribute that, and I just get an is n minus 18. And if I need to find a12, I just put a 12 in for n, and I get -6. Okay? Now we're going to talk about an arithmetic series. Remember when we talked about what an arithmetic series is? It's the sum. So now this is a specific type of sum. It's a sum of an arithmetic sequence. So recall that a series is the sum of a sequence. When finding the sum of an arithmetic series, we use the following formula. Okay, you ready? Sn equals n times a1 plus an over 2, where n is the number of terms and a1 is the first term and an is the last term that you are adding up. All right, so let's look at some examples. Number 12, we got 2 plus 4 plus 6 plus 8 plus ... and we're looking for S10. So in order to find S10, we need, oh, I forgot my parenthesis over here. We need, in order to find S10, we need A1, AN, and so we need A1 and A10 in order to find the series. So A1 equals 2. So A10 is, we can use this formula that we had used before and say A10 is, what is D? Well, if you look at the difference here, it's 2 times 10 minus 1 plus A1. So this is 10 minus 1 is 9, 9 times 2 is 18 plus 2. So A10 is 20. So to find our S10, we're going to use this and put a 10 in for n. So we're going to have 10 times the first term plus the last term and divide that by 2. So that is 22 divided by 2, which is 10 times 11, which is 110. All right, let's look at number, did I skip number 12? That was number 13. I don't know why I wrote number 12. That was number 13. All right, let's look at number 14. We've got -6 plus -19 plus -32 plus -45, and we're looking for S8. So here's A1. We need A8, so we're going to use this, and we have to know what D is. What are we doing to get the next one all the time here? We are subtracting 13. So D is -13 times 8 minus 1. We're putting that because we're looking for 8 plus the first term. So this is -13 times 7 minus 6, and the 8th term is -97. So to find our S8, we're going to take n, which is this, 8 times the first term plus the 8th term over 2, which is 8 times -51.5, which is -412. All right. Two more. Now we're using summation notation. Remember last time when we used summation notation, what does that mean? This is x goes from 1 to 12 of 6x minus 4. Okay, I'm going to put these formulas over here. And 6x minus 4. So in order, what this sum right here is asking us for, it's asking us to add up the first 12. So before, when we did this on the last thing, we would have had to write out when x equals 1, when x equals 2, when x equals 3, when x equals 4, all the way up to when x equals 12, and add all those numbers up. But now we can use this equation because it's an arithmetic sequence. We can use this one, and we only need to know the first term and the last term. So A1 is 6 times 1 minus 4, which is 2. And A12 is 6 times 12 minus 4, which is 68. So now we can say S12 is 12 times 2 plus 68 over 2, which is 12 times 35, which is 420. And the last one that we're doing here is a little tricky, so let's stick with me for a minute. We're going to do the sum of m goes from 8, is that an 8? Oh my word. Um, 8 to 17 of negative 2m plus 3. So now, what is our n? How many terms are we adding up? If we are adding up m equals 8, m equals 9, 10, 11, 12, 13, 14, 15, 16, 17. We're adding up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 terms. So we can't just take 17 minus 8. We have to take 17 minus 8 plus 1. Because look over here. 12 minus 1 is 11, but there's really 12 terms. So remember that you don't just subtract these. So our n is 10. There's 10 terms. And our first term is actually when m equals 8, because that's where we're starting here. So our A1 is negative 2 times 8 plus 3, which is negative 16 plus 3, which is negative 13. And our AN is really when m equals 17. So that's negative 2 times 17 plus 3, which is negative 31. So now we have all our pieces. We have our n, we have our A1, and our AN. So we can say our S10, well, I don't know if we want to call it that. Sure, we can call it S10. Equals 10 times negative 13 plus negative 31 over 2, which is negative 220. And that's the end for this section. Much shorter than the last one.